Okay, guys, the last time we were together, we started talking about representative particles, right? We said what was an atom, ion, molecule, and formula unit. The only thing was that these are the things that we cannot count respectively, so we have to use something known as Avogadro's number so that we can convert to a mole that will allow us eventually to become something that we can measure out, something practical. Avogadro's number again at 6.02 times, 6.02 times 10 to the 23rd, whatever representative particle it is, that will equal 1 mole. And we said that if we wanted to go from representative particle to mole, we'd have to divide by Avogadro's number. And if we want to go from mole to representative particle, then we'd have to multiply by Avogadro's number. Yesterday, or the time we saw each other the last time, which was Monday or Tuesday, we started talking about the molar mass. And the molar quantity is nothing much more of how much each substance or each atom masses respective to the mole. And so based on what we spoke about last time, we were able to determine the molar masses of certain compounds, or even just an individual atom, as we saw right here. First, we'd have to separate the atoms, identify the subscripts, and then multiply the subscripts by mass of each of the atoms, and then add them all up. So now the last thing we have to use is how are we going to use that molar mass so that we can convert from moles to grams. Okay, so if we want to go from moles to grams, you're going to multiply by the molar mass. So I'm going to put right here, multiply by the molar mass. Now, when you multiply by the molar mass, that means you're going to have grams on top and the 1 mole at the bottom, however many grams it is. It just depends on the substance, or atom, molecule, formula unit, whatever the case may be. Now, if we want to go from grams to moles, then we're going to do opposite, the inverse of that. So that means we got to divide, divide by the molar mass. That means here, we're going to have the 1 mole on the top, and then however many grams it is at the bottom. Okay, so I'm going to show you a couple of examples, some examples that you will need for what you're going to do today. Okay, so the first example I'm going to show you is going to be on the worksheet that you picked up today. So I'm just going to go ahead and use it already. And as we can see here, it says for number 19, we're going to go from moles to grams. So then we're going to use number 19. Number 19 states, it says how many grams are there in 5.65 moles? So that means you're given 5.65 moles. And now it's super important of what the substance is. Here we have ammonia, which is NH3. And what you want to do is you want to convert to grams of NH3. Okay, and I want to split it a little down the middle. And so what you're going to do essentially here is you're going to start off with 5.65 moles of ammonia. And then, of course, we're going to do our dimensional analysis. Now, the only thing that you have to do first is the first thing that you have to find out is the molar mass of ammonia. So again, we have to separate everything. We have N and H. Look at the subscripts. Nitrogen, there's a 1 subscript. Well, there's nothing there, so we assume 1. Hydrogen, there's a 3 as a subscript. The next thing you have to do is you look at your periodic table. and you look at the mass for nitrogen, the mass for nitrogen is going to be 14.0, and the mass for hydrogen is going to be 1.0. Now remember, we're rounding to the 10th position. And then you multiply, we end up with 14.0, and then 3.0, you're going to add them together, and we end up with 17.0. And these are going to be grams is equal to, or grams per mole. Okay, now this is 1 mole. So how are we going to use this molar mass? Okay, well, if you notice here, we want grams. So we said originally that if we're going from moles to grams, we have to multiply by the molar mass. So that's what we're going to do. We're going to multiply by that 17, so that means that the 17.0 grams of NH3 goes on top, and then the 1 mole is going to go at the bottom. You'll notice here that these will cancel out. And now all you have to do is multiply 5.65 times 17. Which is which is 96.1 grams of ammonia.